Right. Good afternoon, everyone. Welcome to the class. So we have discussed introduction about demultiplexer. 1:2 demultiplexer, 1:4 demultiplexer, 1:8 demultiplexer, 1:2 power n demultiplexer. One input, multiple outputs. The data available on single input line will be transferred to one of 2 power n output lines based on n select lines. Based on n select lines. So that is the introduction about demultiplexer. Let us see implementations. 1:4 demux using 1:2 demux. 1:2 demuxes. 1:4 demultiplexer implementation using 1:2 demultiplexers. Then what should I do here? One input is there, can be demultiplexed to two output lines using 1:2. And here again demultiplexing using two number of 1:2 demultiplexers. Here it is producing four outputs y0, y1, y2, y3. If I say 0, 1, 0, 1, 1:2, 1:2. What is the select line, sir? What is select line, sir? We can have a first stage is MSB select line, last stage is LSB select line. Exactly reverse for multiplexer implementation. In multiplexer implementation, first stage is LSB, last stage was MSB. Now, first stage is MSB, last stage is LSB. The minimum number of demultiplexers required is also 2, as we have seen on multiplexer implementation. So, whatever that demultiplexers we are getting here, the same number of demultiplexers we have used while implementing multiplexer. So exactly reverse. There it was first stage LSB, last stage was MSB. Now first stage is MSB, last stage is LSB. Let us try one more, maybe getting some more clarity. What is that major difference on multiplexer implementation and demultiplexer implementation? If I say 1:8 demux using 1:2 demuxes. 1:8 demultiplexer using minimum number of 1:2 demultiplexers. Here we have a 1:2 demultiplexer producing two outputs. Again, this is splitted into two parts, producing again four outputs. But what is required number of outputs? 8. Again, we have one more level using 4 number of 1:2 demultiplexers. Four number of 1:2 demultiplexers. Here 0, 1. If I have input data like this, let me see here y0, y1, y2, y3, y4, y5, y6, y7. Then what can be the select lines? Here now MSB is S2. If I say next is LSB, S0. LSB is S0. First stage is MSB and last stage is LSB, and in between we have a S1. See, after implementing this, you may be getting an opinion. Why we are discussing unnecessarily on demultiplexer separately? Whatever the logics we have used on multiplexer are applicable for demultiplexer also. Whatever the logics we have used on multiplexer are applicable for demultiplexer also. Demultiplexer also. And major difference is multiplexer implementation, flipping horizontally, then make I2Y, Y2I. Because there was one output Y that is becoming one input I. There were I0 to I7. Now we have a Y0 to Y7. Just flipping horizontally, make I2Y, Y2I is giving expected logic. I'm not saying that multiplexer is flipped, we are getting demultiplexer. Don't understand that logic. Just logic behind implementations only we can understand from this. So when multiplexer is used, if you are writing reverse, the logic will not be working as demultiplexer. Simply as a block to understand implementation, whatever the multiplexer implementation we have, so those must be flipped, then it is becoming demultiplexer logic. So whatever the logics we have used on multiplexer, like 9:1, 10:1, and so and so. Similarly, 1:9, 1:10, and so and so. We can get the same logics here also. So using demultiplexers, we are implementing higher order from lower order. And whatever the logics we have used on multiplexer are applicable for demultiplexers also. Demultiplexers also. No need to analyze separately for demultiplexers again. Same logics we can use. Similarly, minimum number of demultiplexers equals to minimum number of multiplexers. Inputs are becoming outputs, outputs are becoming inputs. Right now, question is this. Implement f of a comma b comma c equals sigma m of 1, 2, 3, 4 using 1:8 demux and required logic gates. Then what can I say here? The function we would like to implement is f of a comma b comma c equals to sigma m of 1, 2, 3, 4. If I write expression, what is that here? A bar b bar c plus a bar b c bar plus a bar b c plus a b bar c bar. Any questions? I am writing expression. 1 is minterm 0, 0, 1, a bar b bar c. 2 is minterm 0, 1, 0, a bar b c bar. 3 is minterm a bar b c because 0, 1, 1 is minterm. 4, 1, 0, 0, a b bar c bar is minterm. Is equals to what we can write? Just a minute. Now that is equals to what we can write here, pi m of 0, 5, 6, 7. Pi m of 0, 5, 6, 7. Is that right? F of a comma b comma c equals sigma m of 1, 2, 3, 4 means the same I can write it as pi m of 0, 5, 6, 7. Let me write that. So pi m of 0, 5, 6, 7 means a bar b bar c bar plus a b bar c plus a b c bar plus a b c whole bar. Correct? Without this complement, it is f bar. Am I right? Without this complement, it is F bar. F bar whole bar is again F. So this is, if you are expanding, we are getting POS. I hope you are understanding. If you are expanding this, if you are applying De Morgan's here, you will get a resultant, which is POS, which is POS. Let us implement this using 1:8 demultiplexer. Here we have one input and how many outputs? 8 outputs. Just a minute. Okay, sorry for the disturbance. Okay. Here we have a S2, S1, S0. Already we know the output expressions. What is that here? S2 bar, S1 bar, S0 bar, I. S2 bar, S1 bar, S0, I. So and so, S2, S1, S0, I. So if I say Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y7. And here, if you are observing S2 bar, S1 bar, S0 bar, I, S2 bar, S1 bar, S0, I, so and so, S2, S1, S0, I. In place of S2, S1, S0, we are using A, B, C. Then what will be the expressions here? A bar, B bar, C bar, I, A bar, B bar, C, I, so and so, A, B, C, I. So if I is connected to 1, then we are getting expressions. What is that here? A bar, B bar, C bar, A bar, B bar, C, so and so, A, B, C, A, B, C. Then, right, those expressions. Just a minute. A, B, C bar, somewhere it is, all right. Okay, just a minute. A, B bar, C, 5, A, B, C bar, then A, B, C. Once we are getting this, very simple, by observing this equation, what we can write here, sigma m of 1, 2, 3, 4 can be implemented using OR gate. Here we have 1, 2, 3, 4, F, which is SOP. The same we can implement using NOR gate. Am I right? So taking product terms, R of those, then not of this is nothing but a NOR. So I can implement the same using NOR gate with 0, 5, 6, 7. F. Right? So there is a way we can implement the required function we have implemented. So once again, what is it here? When function is specified, we can write expression in SOP, expression in POS. Is it POS or not? If anyone is having any doubt, let me know. It is POS. How it is becoming POS? If you are expanding this, then it is becoming POS. It is becoming POS. So A bar, B bar, C bar whole bar, and A, B bar, C whole bar, and A, B, C bar whole bar, and A, B, C whole bar. Then if you are expanding that, it is becoming POS. It is becoming POS. It is becoming POS. Shubham, can you elaborate your doubt? Without this complement, it is becoming F bar. If you are taking complement again, F bar whole bar is F. Without this complement, it is F bar. If you are taking complement of that, it is F bar whole bar, it is F, which is resulting POS expression. So POS is not directly written. How we are getting POS also we have discussed, Puja. How we are getting POS also we have discussed, right? How we got that first writing F bar in SOP, taking complement of that, then it is resulting POS. Basics of Boolean algebra, Puja. Shubham. If anyone is having any doubt, let me write that. Yes, phi m of 0, 5, 6, 7 means 0 means a plus b plus c. Then what is it here? Let me take people have to follow from basics. So pi m of 0, 0 means what? A plus b plus c. And with phi is nothing but a bar plus b plus c bar. Next 6 is nothing but a bar plus b bar plus c. And with 7 is nothing but a bar plus b bar plus c bar. This is POS, right? If you are expanding this also, what we get here? A bar, B bar, C bar whole bar, and with A, B bar, C whole bar, and with A, B, C bar whole bar, and with A, B, C whole bar. Expand this, what we get? A bar, B bar, C bar whole bar is nothing but A plus B plus C. A, B bar, C whole bar is nothing but A bar plus B plus C bar. And with A, B, C bar whole bar is nothing but A bar plus B bar plus C. And with A, B, C whole bar is nothing but A bar plus B bar plus C bar. We are getting same. Even though you are writing POS directly, even though you are writing that F bar and taking complement, we are getting same. This basics we have discussed already. That's what we are doing. Yes. If I equal to 0, output will be 0. All the outputs are zeros, Triveni. If I equal to 0, what we get here? A bar, B bar, C bar, I. If I is 0, this term is becoming 0. All are becoming zeros. Right? All the outputs are becoming 0. We are not getting function of ABC. Yes. So whatever the way you are understanding, just use that. Right? Okay, okay. No issue, Pooja. Right. Right. That's the way we can implement a logic function using demultiplexer also. Similar analysis we are going to do using decoder. We are going to extend these implementations in decoder because there is a similarity between demultiplexer and decoder. Let us understand what is the similarity between demultiplexer and decoder. Then we extend this discussion. So once we are understanding decoder, there we are going to understand some more analysis about implementations. Until that, hold on. So now let us get into decoder. N inputs to power n outputs. N inputs to power n outputs. What is it? Decoder functionality. What is its functionality first of all? And what is the use of this? All this let us try to understand. So decoder n inputs and to power n outputs. For example, if one input is there, 1 to 2 decoder, 1 to 2 decoder, 1 to 2 decoder, one input, two outputs we have. Then 1 to 2 decoder. If I say one input A and two outputs Y0 and Y1, if I say one input and two outputs, one input is A, two outputs Y0 and Y1. Then what is its functionality? This one input can be either 0 or 1. Depending on this input combination, respect to output n is 0, remaining are respect to output n is 1, remaining are zeros. Now here A equals to 1, Y1 is 1, remaining are. If A equal to 0, Y0 is 1, Y0 is 1, remaining are zeros. If A equals to 1, Y1 is 1, remaining are zeros. Once again, if A equal to 0, Y0 is 1. If A equals to 1, Y1 is 1. May not be understanding correctly what is happening in this, right? So let us try to understand 2 to 2 power 2, that means 2 to 4 decoder. There we can understand clearly. So let me use that 2 to 4 decoder. 2 to 4 decoder. Right? 2 to 4 decoder means we have two inputs A, B, and there are four outputs Y0, Y1, Y2, Y3. These two inputs can be the combinations 0, 0, 0, 1, 1, 0, 1, 1. These are possibilities. 0, 0, 0, 1, 1, 0, 1, 1. For each and every input combination, respective output line is 1, remaining are zeros. So AB 0, 0, Y0 is 1, remaining are zeros. If AB is 0, 1, Y1 is 1, remaining are zeros. If AB is 1, 0, Y2 is 1, remaining are zeros. When AB is 1, 1, Y3 is 1, remaining are zeros. For different input combinations of AB, for each and every input combination of AB, respective output line is 1, remaining are zeros. This is what for AB 0, 0, Y0 is 1, 0, 1, Y1 is 1, 1, 0, Y2 is 1, 1, 1, Y3 is 1. For this decoder, we can have one more signal, which is enable signal. Let us use that enable signal also. So here we have considered without enable. Now let me consider enable signal also. This enable also can be either logic 1 enable or logic 0 enable. Two possibilities. Logic 1 enable or logic 0 enable. Let me use logic 1 enable in this. In this, I'm using logic 1 enable. What do you mean by logic 1 enable? If the signal is 1, then it is enabling AB. It is responding to AB. Expected function we are getting when it is enabled only. So, as it is logic 1 enable, when E is 1, all this function is applicable. When E is 1, all this function is applicable. When E equal to 0, when E equal to 0, it is not responding to AB because it is disabling AB. If E equal to 0, it is disabling AB. It is disabling AB. Then what will be the output? All the outputs are zeros. See, when E equal to 0, irrespective of AB, all the outputs are zeros. Any questions? If E equal to 0, irrespective of AB, all the outputs are zeros. If E equals to 1, depending on AB, respective output line is 1, remaining are zeros. That's what we can say. Logic 1 enable. What do you mean by this? When E equals to 1, if the signal is 1, then it is enabled. When it is enabled, it is responding to AB. Depending on AB combination, respective output line is 1, remaining are zeros. Right? So that is a logic 1 enable. Logic 1 enable. Now let us understand demultiplexer functionality, because we are saying that there is similarity between demultiplexer and decoder. Let us understand that similarity first, then we see how it can be implemented. Now let me write that 1 to 4 demux. 1 to 4 demux. What is it here? One input, four output lines. Four output lines. So let us see what we can have here. Two select lines S1, S0, four outputs Y0, Y1, Y2, Y3. Any doubt in that? When we have two select lines S1, S0, four outputs Y0, Y1, Y2, Y3. Select lines can be 0, 0, 0, 1, 1, 0, 1, 1. So when S1, S0 is 0, 0, what are the outputs we have? Y0 is what? I, input data. I did not say output is 1. Input data will be transferred to Y0 when S1, S0 is 0, 0. What about remaining zeros? For S1, S0, 0, 1, what is it here? Y1 is I, remaining are zeros. When S1, S0 is 1, 0, Y2 is I, remaining are 0. When S1, S0 is 1, 1, what is it here? Y3 is I, remaining are. This is what we know. When S1, S0 is 0, 0, I is transferred to Y0. When S1, S0 is 0, 1, I is transferred to Y1. When S1, S0 is 1, 0, I is transferred to Y2. When S1, S0 is 1, 1, I is transferred to Y3. That's what we know about a demultiplexer function. If that I, if I consider specially, if I is 0, if I itself is 0, what about output, sir? If you remembered output expressions of Y0, Y1, Y2, Y3, S1 bar, S0 bar, I. Y1, S1 bar, S0 I. Y2, S1, S0 bar I. Y3, S1, S0 I. Right? If I itself is 0, irrespective of select lines, all the outputs are zeros. All the outputs are zeros. Right? If I itself is 0, irrespective of select lines, all the outputs are zeros. If I equals to 1, if I equals to 1, that 1 will be transferred to respective output line. Respective output line. That's what we can understand. Try to understand similarity between demultiplexer and decoder by observing these tables. Yes, sir. So what we are understanding here, these two tables are giving same functionality. These two tables are giving same functionality. These two are similar. Then what we can say? Decoder with an enable input is equals to demultiplexer, or demultiplexer also can be used as a decoder with an enable input. Once again, demultiplexer also can be used as a decoder with an enable input. Once again, right, we can say a note here, decoder with enable input is equal to demux, or demux also can be used as a decoder with an enable input. With an enable input. Decoder with an enable input is equals to demultiplexer, or demux also can be used as a decoder with an enable input. So what we are understanding here, Instead of E, we have I. Instead of AB, we are using S1, S0, and all the outputs are same. Then whatever the functions we have observed on demultiplexer can be applied in understanding decoder. Let us see what is it. So already we have seen demultiplexer. Now let me write a 2 to 4 decoder. 2 to 4 decoder. Whatever I is there is becoming as enabled signal. Whatever that S1, S0 were there, those are becoming A, B. Understanding once again? What is it here? So there were S1, S0. Those are becoming now AB as inputs of decoder. There was I that is becoming E. Now we can write 4 outputs. I say now 2 to 4 decoder. Here we say Y0, Y1, Y2, Y3. Understand correctly? What we have written here, S1 bar, S0 bar, I. Now it is A bar, B bar, E. So I write it as E, A bar, B bar. And what about Y1? E, A bar, B. Next, E, A, B bar. Next, E, A, B. I think no one is having any doubt here. See, what is it here? In place of S1, S0, we are having A and B. In place of I, we have E. We have E. Now, whatever decoder we are discussing is a logic 1 enable, logic 1 output decoder. What do you mean by logic 1 output decoder? If you are observing in the decoder, whenever it is enabled, depending on respective input combination, respective output line is 1, remaining are zeros. Once again, whenever it is enabled, depending on input combinations, respective output line is 1, remaining are zeros. Remaining are zeros. Try to understand correctly. When E equals to 1 enable, depending on AB, respective output line is 1. That is called logic 1 output decoder. That is called logic 1 output decoder. Right? The decoder is enabled with logic 1. That is the reason we say that logic 1 enable, logic 1 output decoder. That means what else we can have? Enabling can be with 0 or outputs also can be 0. Logic 0 enable can be there. Logic 0 outputs also can be there. With these possibilities, we are getting 4 different types of decoder. Every decoder is important. So try to understand correctly what is the functionality of this decoder, because they have given very good questions based on this similarity between demultiplexer and decoder also. They have framed a question in 2014 EC paper, 2 marks question. Understand correctly? Similarity is important. Try to understand this. They can frame questions based on any property or any of the topics. So what we are saying here, we can have 4 different types of decoder. One is a logic 1 enable, logic 1 output decoder. So far we have discussed. Other thing is a logic 0 enable, logic 1 output decoder. And third one is a logic 1 enable but logic 0 output decoder. And fourth one is a logic 0 enable, logic 0 output decoder. Let us see one by one. So here I represented, once again I am writing with the headings. First one is a logic 1 enable, and logic 1 output decoder. What is the table? Same table I am writing once again. E, A, B, Y0, Y1, Y2, Y3. If E equal to 0, disabling AB, all the outputs are zeros. Why outputs are zeros? It is logic 1 output decoder. When logic 1 output decoder is there, all the outputs are zeros when it is disabled. When E equals to 1, enabled, depending on AB, AB 0, 0, Y0 is 1, remaining are zeros. If AB is 0, 1, right, Y1 is 1, remaining are zeros. If AB is 1, 0, Y2 is 1, remaining are zeros. If AB is 1, 1, Y3 is 1, remaining are zeros. If E equal to 0, irrespective of AB, all the outputs are zeros. If E equals to 1, Depending on AB, respective output line is 1, remaining are zeros. That's what we can say. Logic 1 enable, logic 1 output decoder. Now what we have represented the circuit, representation is here AB inputs, there is an enable input, there are 4 outputs. That is a 2 to 4 decoder. Y0, Y1, Y2, Y3. Then what we get here? Output expressions also we have written. What is that? E, A bar, B bar. E, A bar, B. E, A, B bar. E, A, B. And if it is required to write the circuit also, let me complete that circuit implementation. A bar. B bar. And also I. Now here we have a 4 AND gates. Y0, Y1, Y2, Y3. A bar, B bar, I. A bar, B and I. A, B bar and I. Here A, B and I. These are outputs. No need to implement if you are understanding, simply I am writing the circuit also. Simple thing is S1, S0, E. S1, S0, E in the previous discussion. Yesterday's demultiplexer, in place of S1, S0, I am using AB. In place of E, I am using I. This is logic 1 enable, logic 1 output decoder. Logic 1 enable, logic 1 output decoder. Yes, E. Yes, it is E. Now, let us say here, logic 0 enable and logic 1 output decoder. What is it here? Enabling with 0, but output is 1 only. So what is it here? You can have logic 0 enabled. Sorry. First, let me write a table. E, A, B, Y0, Y1, Y2, Y3. Exactly reverse with respect to enable. What is it here? E equals to 1, disabling AB, all the outputs are zeros. Why all the outputs are zeros? It is logic 1 output decoder. If E equal to 0 now enabled, AB can be 0, 0, then Y0 is 1, remaining are zeros. When E equal to 0, AB 0, 1, right? Y1 is 1, remaining are zeros. If E equal to 0, AB are 1, 0, then Y2 is 1, remaining are zeros. If E equal to 0, AB are 1, 1, then Y3 is 1, remaining are zeros. That is a logic 0 enable, logic 1 output equal. How do you represent that? Let us see. Understand correctly? Here we have AB inputs. Here enabling. How do you represent the enable? How do you represent enable? Right? There can be bubble, or we can have a E bar also. If you have both, logically you may be thinking that it must be logic 1 enable. Right? Without having bar, if it is having bubble also, logic 0 enable. If you have only E bar, then also logic 0 enable. When we have both, logically you may be expecting logic 1 enable, but representations are indicating logic 0 enable. All these three are representing logic 0 enable only. Don't apply any logic in this. Simply follow. All these three are representing logic 0 enable only. Whenever we have without bubble, without bar, both are not there. Simply E without bubble, without bar. Then it is logic 1 enable. Otherwise, all these three are representing logic 0 enable. So don't apply any logic. If you are applying logic, there is a possibility for getting logical deductions in the number of marks. So blindly follow that. Even though both are there, logic 0 enable only. So why we need to follow that? To get 2 marks. To get 2 marks. Simply giving a caution or warning. If you are applying logic here, there is a possibility for getting wrong answers. Please. Now, so what is the outputs now? Instead of E, it will be E bar. That's it. E bar, A bar, B bar. E bar, A bar, B. E bar, A, B bar. E bar, A, B. Bar. Now, how it can be implemented? A bar. B bar. And also E bar. Then here we have 4 AND gates. Is Y0, Y1, Y2, Y3. A bar, B bar, E bar. A bar, B, E bar. A, B bar, E bar. A, B, E bar. Any more questions? Simple. Logic 0 enable, logic 1 output decoder. What is remaining? 2 more. Logic 1 enable, logic 0 output decoder, logic 0 enable, logic 0 output decoder. Simple thing we can understand from this. See, what we are saying that 2 more decoders, logic 1 enable, logic 0 output decoder. Logic 0 enable, logic 0 output decoder. Simply, whatever the outputs here, just using bubbles at output side is representing logic 0 output decoder. And to get output expression, just take complements of these. Logic 1 enable only. Same thing we are representing here. At output side, we are using bubbles which are indicating complements, which is nothing but complements of these. That is a logic 0 output decoder. And similarly, again logic 0 enable, logic 0 output decoder. Enable side is same. At output side, we are using bubble. Again, complements of these. Again, complements of these. Complete those two if you are writing. What is it here? Here it is a logic 1 enable and logic 0 output decoder. If you want to write a table, very simple. Logic 1 enable, logic 0 output decoder. Y0, Y1, Y2, Y3. If E equal to 0, then irrespective of AB, all the outputs are now ones. Because logic 1 enable means 0 is disabling. 0 is disabling AB. Irrespective of AB, all the outputs are ones. When E is becoming 1, then it is enabled. AB or 0, 0, then why not only 0, remaining are ones? Right? Why not only 0, remaining are ones? When E equals to 1, AB 0, 1, what is that here? Y1 is 0, remaining are ones. When E equals to 1, AB are 1, 0, what is that here? Y2 is 0, remaining are ones. When E equals to 1, AB are 1, 1, what we can write? Y3 is 0, remaining are ones. Done. And complete that representation as well as implementation for this. And one more, I'm writing here. logic 0 enable and logic 0 output decoder. Then what we can write here E, A, B, Y0, Y1, Y2, Y3. If E equals to 1, now it is disabled. Then irrespective of AB, all the outputs are ones because it is logic 0 output decoder. Exactly complements. The table is also complementary. When E equal to 0 enable, AB 0, 0, Y0 is 0, remaining are ones. When E equal to 0, AB 0, 1, what is it here? Y1 is 0, remaining are ones. When E equal to 0, AB are 1, 0, then Y2 is 0, remaining are ones. When E equal to 0, AB are 1, 1, Y3 is 0, remaining are ones. Complete these representations and implementations for these two. One is logic 1 enable logic 0 output decoder. The fourth one is logic 0 enable logic 0 output decoder. Please complete these representations and implementations, everyone. Done. See, let us implement logic 1 enable and logic 0 output decoder. So here, as we already discussed, representation can be like this. Here it is a AB and logic 1 enable and there is a bubble at output side, which is representing logic 0 output decoder. 2 to 4 decoder, and here it is y0, y1, y2, y3. Then what can be that output expression, sir? E a bar b bar whole bar. It is equals to E bar plus A plus B. E a bar b whole bar is equals to E bar plus A plus B bar. E a b bar whole bar is equals to E bar plus A bar plus B. E a b whole bar is equals to E bar plus A bar plus B bar. A bar plus B. And you can do implementations also. Simply in this implementation, if you are using bubbles at output side, which is nothing but NAND gates, or you can use OR gates with complementary inputs. You can use bubbles at output side to get complements. Simply complements of this decoder outputs. E a bar, B bar, whole bar we have used. So E a bar, B bar is implemented. Take bubble at output side. We are getting implementations of this third one, whatever we have discussed. Logic 1 enable, logic 0 output. Complete that implementation if required. The fourth one is what? Logic 0 enable, logic 0 output decoder. As we discussed already, the enabling can be 0 with bar or bubble or both. And input side what we have here? AB. And output side exactly second decoder outputs complements. 2 to 4 decoder. Here it is y0, y1, y2, y3. Then what is it here? E bar, A bar, B bar, whole bar. E bar, A bar, B bar, whole bar is equals to E plus A plus B. Next, E bar, A bar, B whole bar is equals to E plus A plus B bar. And E bar, A, B bar whole bar is equals to E plus A bar plus B. E bar, A, B whole bar is equals to E plus A bar plus B bar. This is what we can say, right? 2 to 4 decoders with logic 0 enable, logic 0 output decoder. 4 different types of decoders. It may be number of inputs and number of outputs may be different, but the classification is based on enabling, based on outputs is logic 1 or logic 0. Logic 1 enable logic 1 output, logic 0 enable logic 1 output, logic 1 enable logic 0 output, logic 0 enable logic 0 output decoders. 4 different types of decoders we have. If it is 3 to 8 decoder, enable ABC 3 inputs y0, y1, y2, y3, 4, 5, 6, 7 equal to 0 irrespective of ABC. All the outputs are zeros. If it is logic 1 enable, logic 1 output decoder. If E equals to 1 enabled, ABC is 0, 0, 0, then y0 is 1, remaining are zeros. If E equals to 1, ABC 0, 0, 1, what is it here? Y1 is 1, remaining are zeros. If E equals to 1, ABC 0, 1, 0, what we can have? Y2 is 1, remaining are zeros. If E equals to 1, ABC is 0, 1, 1, then Y3 is 1, remaining are zeros. If E equals to 1, ABC 1, 0, 0, then Y4 is 1, remaining are zeros. If E equals to 1, ABC 1, 0, 1, 1, 1, 1, 0, then Y6 is 1. If E equals to 1, ABC are 1, 1, then and the representation enable signal, here it is ABC. Then total 8 outputs we are getting. Y0, Y1, Y2, Y3, 4, 5, 6, 7. 3 to 8 decoder. Then what we get here? E, A bar, B bar, C bar. Next, E, A bar, B bar, C. E, A bar, B, C bar. E, A bar, B, C. E, A, B bar, C bar. E, A, B bar, C. E, A, B, C bar. E, A, B, C. E, A, B, C. No need to implement every circuit, just leave it there. That is a 3 to 8 decoder. And 4 to 16, 5 to 32, n to 2 power n. No need to write all those decoders. You can understand. Moving to next slide. Implement 4 to 16 using 2 to 4 decoders. Implement 4 to 16 using minimum number of 2 to 4 decoders. Complete that and tell me the answer. Implement 4 to 16 decoder using minimum number of 2 to 4 decoders. Yes. Right. Yes, let us see how it can be implemented. Now, 4 to 16 decoder is required to be implemented using 2 to 4 decoders, and also 2 to 4 decoders with enable. Let me say that 2 to 4 decoders with enable. These decoders are also having enable signal. Then how it can be implemented? Now let us see what is the function we would like to implement. Let me say that A, B, C, D are inputs. For each and every combination, let us say what should be the function. For A, B, C, D, 0, 0, 0, 0. What we are expecting? Y naught is 1, remaining are zeros. If I consider logic 1 output decoder, for A, B, C, D, 0, 0, 0, 0, Y naught is 1, remaining are zeros. For A, B, C, D, 0, 0, 0, 1, Y1 is 1, remaining are zeros. For 0, 0, 1, 0, Y2 is 1, remaining are zeros. For A, B, C, D, 0, 0, 1, 1, Y3 is 1, remaining are zeros. 0, 1, 0, 0, Y4 is 1, remaining are zeros. 0, 1, 0, 1, Y5 is 1, remaining are zeros. 0, 1, 1, 0, Y6 is 1, remaining are zeros. 0, 1, 1, 1, Y7 is 1, remaining are zeros. 1, 0, 0, 0, Y8 is 1. 1, 0, 0, 1, Y9 is 1. 1, 0, 1, 0, Y10 is 1. 1, 0, 1, 1, Y11 is 1. 1, 1, 0, 0, Y12 is 1. 1, 1, 0, 1, Y13 is 1. 1, 1, 1, 0, Y14 is 1. 1, 1, 1, 1, Y15 is 1. Y15 is 1. These are outputs. When I am mentioning respective output n is 1, remaining are zeros. Remaining are zeros. This should be implemented using 2 to 4 decoders. Now, each 2 to 4 decoder can produce 4 outputs. Let me partition this into 4 parts. Because each 2 to 4 decoder can produce only 4 outputs. Right? Each 2 to 4 decoder can produce only 4 outputs. When we have 16 outputs, to produce 16 outputs, we need 4 number of 2 to 4 decoders in the end stage. In the end stage, what is it here? We need 4 number of 2 to 4 decoders in the end stage. That's fine, but if you're observing clearly, each and every part of these 4 parts, in this first part, AB00 common, second part AB01 common, third part AB10 common, fourth part AB11 common. Once again, first part AB00 common, second part AB01, third part AB10, fourth part AB11. And first part, once again, if you're observing, when AB is 00 common, CD00 Y0 is 1, CD01 Y1 is 1, CD10 Y2 is 1, CD11 Y3 is 1. Once again, when AB01 is common, once again depending on CD, 00 Y4 is 1, 01 Y4 is 1, 10 Y6 is 1, 11 Y7 is 1. Once again AB10 is common, but again depending on CD only, 1 of Y8 to Y11 is 1. Once again, when AB is 1, 1, depending on CD only, 1 of Y12 to Y15 is 1. So each 2 to 4 decoder in the end stage is responding to which input lines? CD. And AB is common. See how it can be implemented. So here we need 4 number of 2 to 4 decoders. 4 number of 2 to 4 decoders which are responding to CD lines. Responding to CD lines. Here we have 4, then 4, then again 4, then again 4. 2 to 4 decoder, 2 to 4 decoder, 2 to 4 decoder, 2 to 4 decoder. Here if I say Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, Y9, Y10, Y11, Y12, Y13, Y14 and Y15. Fine. But AB00 first decoder must be enabled. AB01 second decoder must be enabled. AB10 third, AB11 fourth. So if you are observing how it can be implemented, here it is AB. Here we have 4 outputs. Also it is enabled. 2 to 4 decoder. Let me say internally we have Z0, Z1, Z2, Z3. And this Z0 is connected to enable signals of first decoder. Z1 enable signal of second decoder. Z2 enable signal of third decoder. Fourth one enable signal of Z0, Z1, Z2, Z3. Verify whether it is correct or not. When this is 1, it is enabled, right? When AB is 0, 0, Z0 is 1, Z1, Z2, Z3 are zeros. That means when these 3 are disabled, all these are zeros. As this is 1, it is enabled. As it is enabled, responding to CD. When AB is 0, 0. AB is 0, 0, Z0 is 1. This is enabled depending on CD. 0, 0, Y0 is 1. 0, 1, Y1 is 1. 1, 0, Y2 is 1. 1, 1, Y3 is 1. So when AB is 0, 0, depending on CD, 1 of Y0 to Y3 is 1. First part is done. When AB is 0, 1, Z1 only 1, these 3 are zeros. That means this is the only decoder is enabled. Now depending on CD, 1 of Y4 to Y7 is 1. Yes, correct. Second part is done. When AB is 1, 0, Z2 only 1, remaining are zeros. This is the only decoder is enabled. Depending on CD, 1 of Y8 to Y11 is 1. Yes, third part. When AB 1, 1, obviously fourth part is satisfied. So Don't arrange number of inputs and number of outputs. Most of you have answered it as a 6. I can see what you have done. So you are using that first level 2 A, B, C, D and second level again 4. Is it working as expected? Check. This is expected functionality. Is it satisfying this expected functionality? So logic must be understood correctly. So here we are using enable signal to enable at the next stage. At the next stage. If anyone is having any questions on this implement, because we have been getting questions, minimum number of decoders required. ABCD, Kashyap, ABCD. AB and CD are accepted. AB in the first stage, CD in the second stage. These are inputs only. Total 4 inputs only. Don't look at circuit. Here it must be 4. If you are pulling this, there will be 4 only. Kashyap. It is 1 out of 2 power n. Shivalila. 1 out of 2 power n. Only one output will be different from all. Wait. Prithviraj, wait. Anyone has any questions? If you are understanding correctly, you can use. We can have multiple enables also, we can have Sai Kumar. Simply instead of considering why I have used Z as output in 2 to 4 decoder. Rahul, I'm not able to help you. Yes, so is actually. We will take examples Triveni. You will understand more. Simple thing is observing what we would like to implement. Observing what we would like to implement. We can say how it can be implemented. So 4 to 16. 4 to 16 is to be implemented. So 4 to 16, if I write, I'm not writing all the 16 outputs. Which one is going to be 1? I'm writing for 0, 0, 0, 0, y naught is 1. 0, 0, 0, 1, y1 is 1. And so 1, 1, 1, 1, y15 is 1. In that, what we are saying that in the first part, AB00 common. That means AB00 enabling one decoder. Second part, AB01, right? With AB01, second decoder is enabled. AB10, third decoder. AB11, fourth one. So, depending on AB, one of these 2 to 4 decoders is enabled, and depending on CD, respective output line is 1. That is the logic we have been using. Don't go with formula. Ashish, we can go with logic 0 output also. Right. Complete this. What is the answer for this question? Yes. Many are in right track. Very good. Very good. How many it can be? 9. Because if I use A, B, C, D, E, F, A, B, C, D, E, F, 6 inputs. In the first stage, A, B, C, 1, 3 to 8 decoder, producing 8 output lines. These 8 output lines are used as enable signals of 8 number of 3 to 8 decoders. 8, 8 is 64 outputs it has to produce. Then in the second stage, if I say all the 3 to 8 decoders, 8 number of 3 to 8 decoders are accepting DEF as the inputs, and number of decoders required is 1 plus 8 is 9. Very simple. Once you are understanding logic, that is the reason I have done this much about this implementation. Otherwise, not required. Simply, I can say a number, but there may not be possibility for understanding to analyze questions instead of using dividing and so and so. No. Just understand how it can be implemented. Once you are imagining, you can say what can be the minimum number of decoders required. The minimum number of, yes, sir, I will explain. Right. Total number of inputs is 6 using 3 to 8 decoder. In the end stage, how many 3 to 8 decoders required? 8 number of 3 to 8 decoders. Any questions in that? In the end stage, we need 8 number of 3 to 8 decoders because 8 is 64 outputs. Yes, 8 number of 3 to 8 decoders in the end stage. To enable these, in the first stage, we are using 1 3 to 8 decoder. 1 plus 8 is becoming 9. So when we are analyzing number of inputs also, total number of inputs is 6. First stage I'm using 3 inputs. Second stage I'm using 3 inputs, total 6 inputs. Yes. Very good. People have been analyzing correctly. This one also, try. Yes. Many of you are correct, or most of you, or all of you are correct. At least few have been doing little bit mistakes. I can see what they have done also. Still, some are doing some mistakes. Let us see what is that. So, how many number of 2 to 4 decoders required in the end stage? 16. No doubt in that 16 number of 2 to 4 decoders required in the end stage. That means 16 2 to 4 decoders can be enabled with 16 lines. Where do we have that 16 lines? These outputs. See, already we have implemented 2 stages. We are getting 16 lines. By using that EF in the end stage, we have a 16 number of 2 to 4 decoders. So those 16 number of 2 to 4 decoders can be enabled with these 16 lines. It is not 2 stages. Now we are going to see 3 stages because 2 to 4 decoders we are using. In each stage, I can use only 2 inputs. So 2 plus 2 plus 2, total 3 stages we have. In the third stage, 16 number of 2 to 4 decoders can be enabled with these 16 lines, right? So what is it here? If I would like to go with the analysis, what is it here? AB 1, CD 4, then EF how many? 16, total 21. Arun Revanta, check your mistake. Where you have done a mistake. Some people are saying 17. I can see what they have done. 16 and 1. 16 in the end stage, 1. But with 1 2 to 4 decoder, how can I enable 16 2 to 4 decoders? Not possible, right? So to enable 16 number of 2 to 4 decoders, we need to have 16 lines. To produce 16 lines using 2 to 4 decoders, we need 1 plus 4, it is 5 number of 2 to 4 decoders. Yes. Yes. Right? Yes, Toyakshu. Yes. Anyone is having any more doubts? Now, let us go for implementation, sir, using decoders. Now, question is implement f of a comma b comma c equals to sigma m of 3, 5, 6, 7 using 3 to 8 decoder and required logic gates. Implement f of a comma b comma c equals sigma m of 3, 5, 6, 7 using 3 to 8 decoder and required logic gates. Let us see what is the function we would like to implement. Then we can see how it can be implemented. How it can be implemented. So f of a comma b comma c is equals to sigma m of 3, 5, 6, 7. Sigma m of 3, 5, 6, 7. Let me write expression. Need to understand each and every expression I'm going to write now. Every equation has its own importance. It must be implemented using decoder. With the decoder, how it can be implemented? That is the question. A bar BC plus A B bar C plus A B C bar plus ABC. ABC. And the same I express in another way. A plus B bar plus C bar and with A bar plus B plus C bar and with A bar plus B bar plus C and with A bar plus B bar plus C bar. Whole bar. Check it. If you are expanding this, the equation I have written, second equation, if you are expanding this, what is that here? A plus B bar plus C bar whole bar is A bar B C, first term, plus A bar plus B plus C bar whole bar is A B bar C, plus A bar plus B bar plus C whole bar is A B C bar, plus A bar plus B bar plus C bar whole bar is A B C. The same expression we are getting from this also. The same I am writing in this way. There won't be any difference, it is same. Is equals to pi m of 0, 1, 2, 4. Pi m of 0, 1, 2, 4. Pi m of 0, 1, 2, 4. Correct? Right. Then what can I write? A bar B bar C bar plus A bar B bar C plus A bar B C bar plus A B bar C bar is a whole bar. No one is having any doubt. Is equal to what we can write? A plus B plus C, because A bar B bar C bar whole bar is A plus B plus C, and with A plus B plus C bar, because A bar B bar C whole bar is A plus B plus C bar, and with A bar B C bar whole bar is A plus B bar plus C, and with A B bar C bar whole bar is A bar plus B plus C. Right? Equation number 1, equation number 2, equation number 3, equation number 4. So in this, clearly if you are observing, equation number 1 is SOP. What about equation number 2? Is not POS. Looks like POS, but it is not POS. Why? After applying this complement, I am getting same expression. This is also SOP. Observe correctly. Without this complement looks like POS, but including this complement, if I take complement, we are getting equation number 1 only. That means equation number 1, equation number 2 are representing same, that is SOP only. So looks like POS, no. When I am applying this complement, I am getting same expression. So it is again SOP only. What about this equation number 4? Equation number 4 is POS. Equation number 3 is also POS. Looks like SOP without complement. After applying this complement, I am getting same 4 expression. So 1 and 2 are SOP, 3 and 4 are POS. No doubt in that. Be clear about this, sir. 1 and 2 are SOP, 3 and 4 are POS. 1 and 2 are SOP, 3 and 4 are POS. Understand correctly. 1 is SOP, confirm. 2 looks like POS, but if you are applying complement, we are getting SOP only. So 3 looks like SOP. No. After complementing, if you are including this complement, we are getting same expression, equation number 4, which is POS. Which is POS. Right. Now let us see how it can be implemented. I am using these implementations are important to analyze the questions we have been getting in the exam. So may not be asking you to implement in objective or at this competitive exams, but conventional ESC we have been getting questions. But with respect to this objective exams, it may not be required to know how it can be implemented. But to answer the given questions in less time, all these implementations are helping us. So try to understand this correctly, what we are doing in this. If I use a 3 to 8 decoder with ABC and also enable signal. D to 8 decoder. Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. What will be the output, sir? E A bar, B bar, C bar, E A bar, B bar, C, so and so E A B C. If I say it is enabled by connecting it to 1, by connecting it to 1, what we get here? No doubt A bar, B bar, C bar. Next A bar, B bar, C. Next A bar, B, C bar. Next A bar, B, C. Next A, B bar, C bar. Next A, B bar, C. Next A, B, C bar. Next A, B, C. Once we have these product terms, from the equation we can say equation number 1 can be implemented, equation number 3 can be implemented. As we have seen already in the demultiplexer, similar way, we can implement equation number 1 and equation number 3. So let us see how it can be implemented. So by using OR gate, check it correctly. By using OR gate, 3, 5, 6, 7, F, equation number 1, we are implementing. The same equation number 3 can be implemented using NOR gate with 0, 1, 2, 4. F, equation number 3. Equation number 3. Which one is correct? Both are correct. No need to implement all. One is sufficient. But in the exam, when circuit is given, which one will be given, we don't know. We must know all the possibilities to answer objective questions. Be clear about this. Now, second possible way we can implement is, let me use a 3 to 8 decoder, which is producing logic 0 output decoders with the ABC. Let me use a logic 1 enable only, but here logic 0 output decoder. Right. In this, what is the outputs we have? E A bar, B bar, C bar, whole bar, E A bar, B bar, C whole bar, so and so E A B C whole bar. If E is connected to 1, then A bar, B bar, C bar, whole bar, which is A plus B plus C. Second one, A bar, B bar, C whole bar, A plus B plus C bar. Next, A plus B bar plus C. Next, A plus B bar plus C bar. Next, A bar plus B plus C. Next, A bar plus B plus C bar. Next, A bar plus B bar plus C. Next, A bar plus B bar plus C bar. When we have these sum terms, from this, what we can say, equation number 2 can be implemented, equation number 4 can be implemented. Equation number 2 can be implemented using AND followed by NOT. NAND gate. Equation number 4 can be implemented using AND gate. Check it correctly. Equation number 2, ANDing sum term followed by NOT gate. It is NAND gate. And here it is AND gate. So let us see what is it here, how it can be implemented. Here it is a NAND gate with these. F equation number 2. And similarly, AND gate can be used with 0, 5, 6, 7. F equation number 4. Not required to implement all these. One is sufficient if it is asked in conventional ESC. But for objective, we must know all these. What we need to understand from this, let us see. One by one, we need to understand. If anyone has any questions on this implementation, let me know. I will help you. Ashutosh, not required. It is not required to implement a minimal expression here. When we have a 3 variable function, 3 to 8 decoder, easy to implement because we are getting that all the product terms are all the sum terms. When we have all the product terms, we can implement using OR gate SOP, using NOR gate POS. When we are having that sum terms, we can implement right, using NAND gate SOP, using AND gate POS. That conclusions is important for our objective exam. Let us see what is that. Yes, Naveen, what happened? Type in the chat box. Your wish. Shubham, you can take any gate. But when already implementation is given, you must know all to answer the questions. Anand, not required to come. That's what I'm saying. Not required to consider all. I'm not saying that you need to implement all. One is sufficient. In all these 4, you can implement any one. Because all these 4 outputs are correct. 1, 2, 3, 4. All these 4 expressions are giving same functionality. All these 4 expressions are giving same functionality. Right. Your wish. You can use a logic 1 output decoder. Bharat, your wish. If it is conventional, you can go with whichever is comfortable to you. That is not mentioned. Right. Suryateja, I'm going to confirm all those, conclude all those because we need to understand all these. Whoever is raising the hands, please down the hands. I'll give you a chance at the end. Naveen and Rajita, Ranjita, Harsha. Right, please. Down the hands. We'll discuss at the end. Until that, please hold on. So, how am I taking that these different gates? I'm going to conclude. Right. See, if you are observing equation number 1, when product terms are there, what should I do? ORing, right? When respective product terms are available, which gate I can use to implement equation number 1? OR gate, confirming OR gate. And coming to equation number 3, when product terms are there, taking OR followed by NOT. What can be the gate? NOR gate. Am I right? When you are implementing equation number 3, clearly it is obvious. What is it? ORing of product terms, not of that. ORing of product terms, not of this. It is NOR gate. It is NOR gate. Correct? And coming to sum terms, when sum terms are available, which gates can be used? If you are observing equation number 4, it is ANDing sum terms. Any difference in that? Yes, sum terms are available with respect to each and every combination. We are taking AND of those sum terms. And after that, we are observing equation number 2. What is it here? Ending the sum terms followed by not. And followed by not is NAND. Once again, equation number 1 is OR gate. Equation number 2 is a NAND gate. Equation number 3 is a NOR gate. Equation number 4 is a AND gate. Depending on available, which gates can be used. When product terms are available, we can implement using OR gate and also NOR gate. When you are having that sum terms, equation can be implemented using either NAND gate or AND gate. And one more things we know. What is that here? Equation number 1 is SOP. What is equation number 2? Is also SOP. Equation number 1 is SOP. Equation number 2 is also SOP. Equation number 3 is POS. Equation number 4 is POS. 1 and 2 are SOP. 3 and 4 are POS. So 1 and 3 are implemented in the first decoder. So this one is SOP, this one is POS. And here, this one is SOP, this one is POS. Because ending is POS. Equation number 4 is POS. 1 and 2 are SOP, 3 and 4 are POS. So when I'm using logic 1 output decoder, it can be implemented using either OR gate or NOR gate. OR gate implementation is SOP, NOR gate implementation is POS. NAND gate implementation is SOP, AND gate implementation is POS. That's it. Right. Right. NAND gate implementation is SOP, AND gate implementation is POS. One more important things we need to observe. So whatever we have discussed here is a OR. Here OR is SOP, NOR is POS. Here NAND is SOP, AND is POS. Now, a simple way. For OR gate, what is the inputs is connected? 3, 5, 6, 7. According to the function 3, 5, 6, 7 are minterms. NOR connected to 0, 1, 2, 4. According to function, these are max terms. So OR gate implementation is SOP, OR gate inputs are minterms. NOR gate implementation is POS, NOR gate inputs are max terms. NAND gate implementation is SOP, again 3, 5, 6, 7 are minterms. AND gate implementation is POS, these are max terms. One by one, once again. OR gate SOP, inputs minterms, because 3, 5, 6, 7 are minterms. NOR gate POS. So 0, 1, 2, 4 are max terms. NAND gate is SOP. NAND gate is SOP. Again 3, 5, 6, 7 are minterms. AND gate is POS. Again 0, 1, 2, 4 are max terms. 1 and 2 are SOP, 3 and 4 are POS. And here, some of you may be getting a doubt. Why can't I use logic 0 enable? Yes, you can use. But it must be enabled by connecting to you. These are also possible. These are also possible. Yes, again I can use logic 0 enable, enabling. First it must be enabling, then enable responding to the inputs. If anyone has any questions with respect to these implementations, let me know. Surya Teja, I hope I answered your question. In equation 2, if you are not having complement, it becomes F bar. F bar SOP. Bhaskar. Bhaskar, if you are not having complement in equation 2, if you are not having complement, what will be there? It is a POS. It is POS of F bar. It is POS of F bar. Check it correctly. In equation number 2, if you don't have this complement, it is POS of F bar. It is not POS of F. POS of F is this. Don't get confused. Bhaskar. Right. Why we have to do complement of first equation? Am I doing complement of first equation? No. Am I taking complement of first equation? Where is that complement of first equation? Nowhere I am having that. To get this, I am writing another expression. This is not complement of this. To get this one, I can apply this complement of this POS. Check it correctly. Surya Teja. Don't get confused. How we got POS equation? Naveen, I spent almost 2 hours on SOP POS, canonical standard POS, and how we are getting that F bar, how we are taking complement of that to get F in POS. Please go through that. Naveen. Yes. Spend effective time on those discussions. You will get more clarity of this. Final conclusions is right. Right. So finally, what is it here? One and two are SOP. It looks like POS, but it's not POS. It is the SOP only. 3 and 4 are POS. 3 and 4 are POS. Not required. When we are using 3 to 8 decoder, 3 variable function, 3 variables can be connected to inputs. Don't get confused. Observe correctly. Yes, yes, Pratik Pramod, I'll do. Because let them get clarity, because they have to get 2 marks. That's my intention. If there is a question from decoder or demultiplexer, they must be in a position to answer. When we are not getting question on multiplexer, most of the time we have been getting either demultiplexer or decoder. Manisha, again you are doing a mistake. It is not dual. It is not dual. With respect to 0, 0, 0, min term is A bar, B bar, C bar. What is max term? A plus B plus C. A bar, B bar, C bar, dual is not A plus B plus C. Right? Manisha. A bar, B bar, C bar is min term with respect to 0, 0, 0 combination. With respect to 0, 0, 0 combination, max term is what? A plus B plus C. Why are you getting confusion? Right? Yes. Whenever it is 1, it is considered as a min term. When it is min term, it cannot be a max term. A combination in min term means it cannot be a max term. How can it be both? No. With respect to function, we decide which are min term, which are max terms. Right? I will do. Praneet, I will do. Right? Let us see how we can get questions in objective exams based on these implementations. So what we have done here, again 4 more possibilities when I'm using logic 0 enabled decoders. So some people were asking which one should I use? In all these 8 implementation, any one you can implement if it is a conventional question, if it is not specified anything. That is not specified anything, you can go with any, not a problem. Yes, we do. We do. How we can get questions. Right. Let us see. Usha, what happened? In the following circuit, output F is. In the following circuit, output F is. Yes, we take a breaker. Don't worry about a break. We'll take the break. From tomorrow onwards, schedules may be changing on request of some students with fresh mind. We discuss in the morning. Is that fine? I will mention all that schedules. Please wait. What time? At 6 o'clock? 6 o'clock in the morning? We'll see. I will announce the schedule, sir. Don't worry. Ashish, it may be a bit later. Just earlier than that, I will announce that schedule, sir. If possible, we do that. Pranita. We'll see. Please wait. Answer here is very simple. Answer is A bar, B bar. Why? NOR gate, POS, 1, 2, 3 are max terms. Then 0 is min term. 0 is min term is AB 0, 0, output is 1. What is that? A bar, B bar. No need to spend time also. By looking at circuit, we can say what is the answer. NOR gate implementation, POS. NOR gate inputs are max terms. 1, 2, 3 are max terms. 0 is min term. 0 is min term means output expression is what? A bar, B bar. Correct. Correct. Otherwise, if you are not accepting, see, yeah, I forgot to mention here, it is 1. It is 1 enabled. Now, what can be the F? Let us see. Then what we get here? It is A bar, B bar. It is A bar, B. It is A, B bar. It is A, B. Then what is the F? NOR of these. A bar, B plus A, B bar plus A, B whole bar. Then what is this here? A plus B whole bar. Check it. A bar B plus AB bar plus AB simplifying, it is A plus B whole bar, which is a bar B bar. Even though you are simplifying, getting same. By observing what is it here? NOR gate implementation, inputs are max terms, 1, 2, 3 are max terms, then 0 is min term, then AB 0, 0 output is 1, A bar B bar. A bar B bar. Simple way we can answer. Your wish. If you are comfortable with the simplifying and saying the answer, or by looking at circuit also we can say. That's what I've been saying. The previous discussions, if you're observing, those can help you in answering these questions easily. Then what is the F here? Options are same. How do you know, Praneeth? Already schedule is updated. Yes. Very simple way we can say NAND gate implementation is what? SOP. That means 0, 1, 2 are min terms, 3 is max term. That means AB 1, 1 only, F is 0. Then what is it here max term? A bar plus B bar. A bar plus B bar. Simple way, what is it here? NAND gate implementation is SOP. That means 0, 1, 2 are min terms, 3 is a max term. When 3 is max term, AB 1, 1 only output is 0. What is expression directly? Max term A bar plus B bar. Only one max term is there. Directly writing that expression A bar plus B bar. If you are not accepting this, go with the what is it? Simplification. Simple way. What is it here? One by one, if you are writing output expression, what is it here? A bar B bar whole bar, A bar B whole bar, A B bar whole bar, A B whole bar. Then take NAND of this. What is it here? A bar B bar whole bar and A bar B whole bar and A B bar whole bar and again bar NANDing. Then what we get here? A bar B bar plus A bar B plus A B bar. A bar is repeated, B bar is repeated. A bar plus B bar. A bar plus B bar. This way we can get questions. Just look at these. You may be getting right ideas. How can we get questions in objective exams as well as conventional also. Your wish. Whichever is comfortable to you, you can use that. If bubble is there on enable, then it is correct. Pranit. Yes. Yes. Yes, sir. We take a small break and we will continue after the break. Right. Any doubt? Yes, if it is logic 0 enable, no doubt it must be enabled by connecting to 0, because to get a function of AB, it must be enabled. If it is used logic 0 enable, it must be connected to 0, then only it is working on AB. It is a function of AB. For that, it must be enabled. It must be enabled. Someone was asking the doubt, Nitish. Any more doubts? Yes, I will do. If E is 0, there won't be any function in these cases. What are the examples we have seen in that if E is 0, there won't be any function. Yes, Pooja. In this, if you are getting that enable is 0, there won't be any function on AB. What is the function F it is implemented? What is the function it is implemented F? What is the function we are getting? Yes. Very good, Ashish. See, very simple. What is happening here? Decoder is disabled. You need to understand that first. Decoder is disabled. Correct? Because it is logic 0 enable. Disable or enabled? Disable or enabled? It is enabled only. It is enable. If I connect to 1 here, it will be disabling. Check it correctly. As it is logic 0 enable, it is connected to 1, then it will be disabling. When it is disabling, what will be the output, sir? 1, 1, 1, 1. Why? It is logic 0 output decoder. As it is disabled, all the outputs are 1, sir. F will be 1. F will be 1. When it is disabled. When it is disabled. But whatever I considered was enabling. Enabling. Check it correctly. It is enabling only. Yes, it was 0. That is indicating it is enabling. Then what will be the function? This is AND function of 0, 2, 3. These are max terms. So F equals to G, F equals to pi m of 0, 2, 3. Why? AND gate which is resulting POS. And these are max terms. Then it is equals to sigma m of 1 is nothing but A bar B. Is nothing but A bar B. Sigma m of 1, AB 0, 1, function is 1. So resultant is A bar B. Any questions? If you are not accepting that, let us see what can be done. Output here is A bar B bar whole bar. Here A bar B whole bar. Here A B bar whole bar. Here A B whole bar. Then what we get here? It is equals to AND of these A bar B bar whole bar and with A bar A B bar whole bar, A B bar whole bar and A B bar. Then what we get here? A plus B and with A bar plus B and with A plus B. Sorry, A bar plus B bar. Then you can AND these, resulting will be A bar B. Check it. Resultant will be A bar B. Try and simplify this. You will be getting A bar B. A bar B. It is A bar B. Because AND gate 0, 2, 3 are connected. That means 0, 2, 3 are max terms. 1 is a min term. 1 is min term means AB 0, 1 output is 1. Functionality. It will be A bar B. It will be A bar. Right. Yes. Yes. Now. Encoder. To power n inputs to n outputs. To power n inputs to n outputs is an encoder. 2 power n inputs to n outputs is an encoder. Exactly reverse operation of decoder is encoder. Exactly reverse operation of decoder is a encoder. So, for example, if I say 422 encoder, then 4 inputs, whatever the decoder outputs y0, y1, y2, y3 are there, those are becoming inputs I0, I1, I2, I3. And whatever that AB inputs for decoder are becoming y1, y0 outputs. So what is the possible inputs now? 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. 1 out of 2 power n. 1 out of 2 power n. That means in these, if you are observing, only one input is 1 out of 4 inputs, out of 2 power n inputs. That means the possible combinations we are considering only 4. Because inputs are mutually exclusive. When inputs are mutually exclusive, then here we have 4 inputs means only 4 combinations possible. Right? You understand correctly? When we have 4 inputs, and inputs are mutually exclusive. Inputs are mutually exclusive. For each and every possibility, if you are observing, what is it here? Only one input is 1. That means if 1 is 1, all the remaining must be zeros. That we can name it as mutually exclusive inputs. When we have mutually exclusive, when we have 4 inputs, only 4 combinations possible. So each and every combination we are representing using 4-bit vector. No. Let me code into 2 bits because 4 possibilities can be coded with 2-bit vectors. Understand point correctly? When we have that mutually exclusive inputs and also considering here 4 inputs, when it is mutually exclusive, only 4 possibilities. Each possibility is differentiated with a 2-bit vector. Why? 4 possibilities means how many bits required? 2 bits is sufficient to differentiate 4 possibilities. Then what we can write here? 0, 0, 0, 1, 1, 0, 1, 1. This is called encoding process. What is here? When we have that mutually exclusive inputs, we have only 4 possibilities. When we have only 4 possibilities, why should I represent using 4 bits? These combinations I am coding into 2-bit vectors. So I have that predefined information which vector of 2 bits is representing which possibility. We have 4 possibilities. Each possibility is represented with a 2-bit vector. With 2 bits we are getting 4 combinations, right? So each possibility is represented with the 2-bit vectors. 2-bit vectors. Now, what is the use of this? What is that happening in this? If you are understanding a simple concept, we can take to understand this concept. So what is it here? If it is right, 1 out of 2 power n, possibility is what? 1 out of 2 power n, or which is we can say mutually exclusive, right? Now, what can be the examples is there are 4 transmitters. Simple example, I'm considering 4 transmitters are competing to transmit the data. Example only to understand the concept. When 4 transmitters are competing to transmit the data over single transmission line, at given instant of time, only one transmitter can transmit the data. At given instant of time, only one transmitter can transmit the data. Which transmitter is that? Whichever the transmitter is enabled. Whichever the transmitter is enabled. That means, let me say here, I0, I1, I2, I3 are enabled signals of transmitters. If I0 is 1, that means T0 is enabled. Remaining should be disabled, means I1, I2, I3 must be zeros. If I1 is 1, T1 is enabled. Remaining must be disabled, is zeros. When I2 is 1, T2 is enabled. Remaining must be disabled. When I3 is 1, T3 is enabled. Remaining must be disabled. That means I0, I1, I2, I3 are enabled signals of transmitters. If I say all these are mutually exclusive. Why? At given instant of time, only one transmitter should be enabled. Then I0, I1, I2, I3 are mutually exclusive. For example, I0, I1, I2, I3 is 0, 1, 0, 0, 0, 1, 0, 0. Then I1 is 1. I1 is 1. Then T1 is enabled. T1 is enabled. T1 is going to transmit the data. T1 is going to transmit the data. But receiver doesn't know which one is transmitting the data. Receiver doesn't know which one is transmitting the data. T1 is enabled, T1 is going to transmit the data, that we can understand at transmitted end because we have I0, I1, I2, I3 is 0, 1, 0, 0. With this we can confirm, yes, T1 is enabled, T1 is going to transmit the data. But receiver doesn't know which one is transmitting the data. So we need to convey that T1 is enabled, T1 is going to transmit the data. For that, available information with us is I0, I1, I2, I3. I0, I1, I2, I3 is signals we have to understand which one is enabled, which one is going to transmit the data. I can transmit these 4 bits as it is. I can transmit these 4 bits as it is to convey T1 is enabled. Or the possibilities, if you are understanding, either T0 or T1 or T2 or T3. Only one is enabled at given instant of time. At a given instant of time. Understand correctly? At given instant of time, only one is going to transfer the data. Which one is going to transfer the data can be conveyed using only 2-bit vectors for each and every transmitter. Let me code into 2 bits. What is it here? T0 ID is 00, T1 is 01, T2 is 10, T3 is 11. If I give this 2-bit code for conveying that ID of transmitter, I'm conveying that ID of transmitter. That means this information will be encoded into 01. It is 01. So instead of transmitting 4 bits, now I'm conveying that same information using only 2 bits because 4 possibilities, either T0 or T1 or T2 or T3. That means 4 possibilities can be differentiated using 2-bit vectors. I'm giving a code for T1, that is 01. That is 01. Right now at receiver end, it is receiving 01. Then what should I do? I have again 4 receivers. I need to enable only R1 because for this given information, T1 is enabled, T1 is transmitting. Then R1 only should be enabled, R1 must be receiving. So by receiving 01, I need to enable only R1, remaining should be disabled. Then what should I do again? What should I do? Decoding. Encoded information is received at the receiver end. Again, I'm decoding, and decoder outputs are used as enabled signals of respective receivers. Decoder outputs are used as enabled signals of respective receiver. Check it out. When 01 is received, which is encoded information while transmitting, then it is enabling only R1, remaining will be disabled, right? So whenever you are conveying information using less number of bits, there I'm using encoder. Whenever it is required to enable only one block, there I'm using decoder. Decoder is used to enable only one block among multiple. Wherever it is required to enable only one among multiple, there I can use decoder. Or simply when we have multiple ICs, I want to enable only one IC, there I can use a decoder. When we have multiple ICs, from that if you are required to enable only one, there I am using decoder. This can be used in constructing higher order memories using lower order memories also. When we are using multiple ICs, for example 4K memory is required, 1K memory ICs are available. So for depending on address combinations, I need to enable one of these 1K memory ICs. For address range, for one address range, first one, next address range, second one, third address range, third one, and fourth address range or last address range, these fourth one should be enabled. So wherever it is required to enable respective ICs, there we are using decoder. Here also only R1 should be enabled, remaining all should be disabled. Not only with 4, we can have the 2 power n multiple also. In such case, one should be enabled, all the remaining should be disabled. There we can use a decoder. That is the reason we say that decoder can be used to generate chip select lines. When we have multiple ICs, to enable only one from multiple ICs, there I can use a decoder. When we have multiple blocks, when we want to enable only one block, there I can use a decoder. So decoder can be used to generate chip select lines or IC select lines. You can use. So finally, what is it here? It is encoding into less number of bits. It is decoding at the receiver end and enabling only one block which is to be enabled. So then decoder can be used to generate chip select lines or IC select lines. Now, in this, if it is all zeros, what should be the output? What do you mean by this, sir? What do you mean by this, sir? None of the transmitter is enabled. Then what it has to convey? Which one is going to transfer the data? Point should be understood correctly. Logic you can understand. Instead of remembering like this, if you are understanding this logic, it will be very easy. Be clear about this. What is it here? What it is conveying as encoder output? ID of transmitter. What is that ID of transmitter? Which transmitter is going to transmit the data? That ID will be transmitted. When all these are zeros, none of the transmitter is enabled. Then what should be the encoder output? ID of transmitter. When transmission is not there, what should I convey? Nothing is required to convey. Whenever it is transmitting the data, ID of transmitter should be conveyed by encoder output. But when transmission itself is not occurring, then I don't need to convey anything. I don't care what it gives output. So what is its duty? Whenever it is transmitting the data, it has to convey ID of transmitter. But when transmission itself is not there, that means this network is ideal. It is not used for transmission. Then what it has to convey? ID of transmitter. Transmission is not there. How can I transmit the ID? Right? So I don't care what it is transmitting the data. For all zeros, when mutually exclusive input is considered, so for each and every input possibility, there is a 2-bit vector. Because we have only 4 possibilities, all those 4 possibilities are encoded into 2-bit vectors. 2-bit vectors. 2-bit vectors. Right? I hope you have understood this concept. Now, in this, what I considered inputs are mutually exclusive. That means at given instant of time, only one input should be 1. At given instant of time, only one input should be 1. If not mutually exclusive, that means more than one input is 1. Understand point correctly. If not mutually exclusive, what do you mean by this, sir? More than one input is 1. Simple thing, simple concept. One by one, once again. In this, we have considered inputs are mutually exclusive. Then concept is very clear. When inputs are mutually exclusive, right? 4 possibilities are there. Each and every possibility is represented with the 2-bit vector, 4 possibilities. But inputs are not mutually exclusive. That means more than one input is 1. How you are going to encode? How you are going to encode? Now concept is helpful. When inputs are mutually exclusive, only one input is 1 at given instant of time. Now I'm saying that more than one input is 1. That is indicating more than one transmitter is enabled. Correct? When more than one input is 1 is indicating more than one transmitter is enabled. But I cannot transmit the data from multiple transmitters. Once again, if more than one input is 1, is confirming that more than one transmitter is enabled. When more than one transmitter is enabled, I cannot transmit the data from multiple. I can transmit data from only one. Which one is that? Which one is that? Priority one. When more than one transmitter is enabled, when I can't transmit the data from multiple, I can transmit data from only one. Which one is going to be that? Priority one. According to predefined priority, it is getting selected data from only one, which is priority one, even though multiple transmitters are enabled. Yes or no? Concept will help you in understanding all these. Encoder, priority encoder. When do we get priority? When there is a possibility for getting multiple inputs at once. Or with respect to this transmission, when more than one transmitter is enabled, data cannot be transmitted from multiple. Data can be transmitted from only one, even though multiple transmitters are enabled. Then, which one is going to be transmitting? Data is defined, priority is decided. If it is a predefined priority is there, then we can decide. That means if I consider a priority like this, I naught greater than I1 greater than I2 greater than I3. If I use this priority. Priority is not fixed. For this priority I'm writing. You can write your own priority, not a problem. Then how it will be? I0, I1, I2, I3 and Y1, Y0. If I0 is 1, what is that here? Highest priority 1 is 1. Remaining may be either zeros or ones. Maybe enabled, maybe disabled. That means it can be any values. For all these possibilities, priority must be given to I0 because according to predefined priority. Among all, I0 is getting highest priority. If I0 is 1, all the remaining may be zeros or ones. Priority should be given to I0. What is I0 ID? 0, according to our predefined. If I0 is 0, then next priority will be given to I1. Remaining may be zeros or ones. Then what is it here? It is 0, 1. Why? When this is disabled, next priority for I1. Remaining may be either enabled or disabled. Then priority will be given to I1 only. Now, if it is 0, 0, 1, this can be anywhere. What do you mean is when these two are disabled, we are getting priority for I2. Then it is 1, 0. When these three are zeros, this is 1, then least priority 1 is getting a chance for transmission of data. Once again, for all zeros, we don't care. This is a priority. Priority. According to predefined priority, the table is changing. For this defined priority, I0 greater than I1 greater than I2 greater than I3, this is a table. So highest priority 1 is ready for transmission, priority will be given for that. If not that, next priority 1. If not these two, third priority 1. If not these three, fourth priority 1. If not, means we are representing with zeros. If highest priority 1 is enabled, then remaining may be enabled or disabled, doesn't matter. It will be given priority to highest priority 1. If not that, next priority 1. If not these two, next priority 1. If not these three, next priority 1. So, if priority is changing, again table will be changing. Table is changing. If priority is changing, table is also changing. Yeah, very good. Very good, Pawan. Right. Very good. Yes. So, here we go with the priority encoder. When we have priority encoder here, there must be priority decoder. Is it required? Not required. Even though you are using here priority, it is transmitting data from only one. Which one is that? Given by priority encoder output. Then just decoder is sufficient. That is the reason we don't have a priority decoder. Anyone has studied priority decoder? No. Priority encoder is there, but priority decoder is not required. When you are getting data from multiple, then I have to choose one. Then we should go with priority. But I'm getting data from only one. When I'm getting data from only one, why do we need to use priority again? When we have multiple, we go with priority. I'm getting only one. Then I don't need to have priority decoder. Just decoder is a sufficient. Decoder is sufficient. I hope you are following. I hope you are following. Right? That is a encoder and a priority encoder. So you want me to write another priority order? Okay. Why should I disappoint you? Let me take a look. I7 greater than, I6 greater than, I5 greater than, I4 greater than, I3 greater than, I2 greater than, I1 greater than, I0. Go with the 8 to 3 priority encoder. Then I0, I1, I2, I3, I4, I5, I6, I7. Then let me use Y2, Y1, Y0. Why should we go with the 4 to 2 on? Let me go with the 8 to 3 priority encoder with these priority order. If I7 is 1, remaining maybe zeros or ones, doesn't matter. Then it will be 1, 1, 1. It will be 1, 1, 1. When this is 0, next priority will be given to I6. Remaining can be either zeros or ones. Then priority will be given to I6, 1, 1, 0. When these two are zeros, then priority will be given to I5. And what is here? 1, 0, 1. When these three are zeros, then what is here? 1, 0, 0. When these four are zeros, right? 0, 1, 1. These are zeros, then priority will be given to I2, which is a 0, 1, 0. And these are zeros, then priority will be given to I1, even though there is I0. When all these are zeros, then priority will be given to I0. When all these are zeros, what is here? Manisha, not only with 4 to 2, I wanted to use right 8 to 3. Okay. If you want me to do that irregular order, okay. Okay. Let me take. Okay. Okay. Let me take order is like this. I0 greater than I2 greater than I3 greater than I1. Okay. Then I0, I1, I2, I3. Y1, Y0. If I0 is 1, remaining may be either zeros or ones. It will be 0, 0. 0, 0. Now, if I0 is 0, if I0 is 0, next priority for I2, these two may be zeros or ones. Then it is a 1, 0. When this is 0, this is 0. Next priority for I3. That means if it is 1, this I1 may be 0 or 1. It will be 1, 1. When all these are zeros, then least priority one is I1. It is 0, 1. 0, 0, 0, 0. Again. Manisha, done? Happy? I will give you. Okay. Prithvi Raja, please check the priority order. What do you mean by that, Raviteja? If you are designing, then specification guy will maybe give. If you are a designer, specification guy may be there. If you are writing an exam, examiner or questioner will be giving that. Raviteja. If you are writing exam, examiner will be giving. That is, XOR and XNOR can be used for parity checking. It's not priority. Right? Parity generation, parity checking. Depending on odd parity or even parity, you can go with that. The network is ideal condition. So is actually. Right. What are your doubts from KMAP? What are your doubts from KMAP? Right. Sorry for the interruption. Not from my side. It's a power failure. Okay. Thanks for waiting. Do you have any questions from? You can draw that circuit, Manisha. You can draw the circuit. Depending on its function, you can proceed. What will be the outputs, right? Instead of using I0, I1, I2, I3, you can use A, B, C, D variables also. And where it is one output, you can observe. Simple circuit, you can draw. Not a big deal. Just writing output expressions for all these combinations. For 1, 8 to 15, and these are combination 8 to 15. And here it is one for 1, 1, 0, 1, 1 combination. Here it is one for all zeros ones. You can write expression for y1 and y0 using 4 variable K map. Using 4 variable K map. Try. If you are not able to do, I will help you. Right. Why not priority decoder? Okay. Yeah. Why not priority decoder? If you have a doubt, let me do that. So when we have a priority encoder, it is encoding according to predefined priority. But are we getting data from multiple to select one from multiple? Are we getting data from multiple? Just a minute. I need a annotation. Yes. So are we getting data from multiple? No. When do we need priority? When we are getting multiple. When multiple data is available, then I have to select one. But I have only one input data. Only one input data. Why should I have a multiple? Why should I have multiple? So why should I have priority when I don't have multiple? So I'm getting data from only one because here it is itself, it is suppressing selecting data from only one. Selecting data from only one, it is suppressing remaining data. It is received only one data. It is received only one data. Then why do I need to have that priority here when I have only one? Here there were multiple, but here we have only one. Then why should I have a priority? I think someone was asking this doubt. Yeah, yeah, Ashutosh. Ashutosh. Yes. So till now I received a request for 6th question and 9th question from KMAP. It will not be multiple outputs. See, their decoder is there. We are getting a code which is saying that which one has to get the data. See, Ashutosh, don't understand in a wrong way. It is not getting by multiple output or receivers because here it is going to be enabled only one because decode with the code encoded information, it is decoding, then only one output is one and all the remaining are zeros. There it is enabling only one. Ashutosh. Yeah, please wait for question hour. I will help you more about this. Right? So Yes, it can be done. Anand, it can be done. Right? Okay. So let me get that question, sir. Many of you are requesting for a question number 6. Very simple question. Let me do that. Question number 6. Question number 6. What is it here? I hope everyone is having that question, sir. The number of minterms after minimizing the following Boolean expression is. If you are observing, given is see D bar plus AB bar plus A bar C. Correct me if I am writing wrongly. A C bar D plus A bar C bar D whole bar. I need to find number of minterms of this function. D bar plus AB bar plus A bar C plus AC bar D plus A bar C bar D. A bar C bar D. So let me say it is a F bar. Example F bar. Let me write K map for F first. Let me write K map for F. Forget about the complement bar. Now let me write K map for F. Here it is a B C D 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Now D bar. What do you mean by D bar is a term when D equal to 0, A, B, C are all possibilities means this is a region. Some people were asking or requesting how to write K map when expression is given. This is the way we need to write it. So D bar means D equal to 0, A, B, C are all possibilities. Check it correctly. So D bar is the term, first term. Forget about this complement. I will include this complement later. So D bar is the term, first term means D equal to 0 region AB or ABC all possibilities. AB 0 0 0 1 1 0 1 1 and C also 0 and 1. Right? This is the region. What is it here? D bar. Any questions? I am writing D bar like this. Forget about this complement. I am writing K map for this F. Assuming it is F bar, I am writing K map for F. Now, second term is what? AB bar. See here, AB bar. That means AB 1 0. There it must be all minterms. AB bar. This is a region for AB bar. There it must be minterms. Any questions? This is AB bar. Second term is completed. What is third term? A bar C. A equal to 0, C equals to 1. This is a region. That means these are minterms. A bar C. This region is what? A bar C. Because A equal to 0, B is changing. C equals to 1, D is changing. So A bar C. And what is third term? Sorry, fourth one. A C bar D. So A is 1, CD 0, 1. That means these two. This is the AC bar D. Check it correctly. A is 1, CD 0, 1. That means these two. That means here it must be minterm because these two must be minterm. According to the fourth term, AC bar D. These two must be minterm. Next, A bar C bar D. A bar C bar D. A bar C bar D. That means these two must be minterm. Right? For F, this is only max term, right? Yes or no? This is only max term we have. For F, if I take F bar, minterms are becoming max terms are becoming minterms. Then if you are taking complement of this function, what happens here? Whichever the min terms are there for f are becoming max terms. Whichever max terms are there, those are becoming min terms. Right? Otherwise, what I can do? Let me simplify this. This is one octave. This is another octave. This is one more octave, and this is another octave. If you write what we get here, it is A bar. And what else next? It is B bar. And vertically, what is it here? Here it is C bar. And to ends, it is a D bar. And again, bar is there. Complement we have neglected, right? Now, what is the resultant of this? A, B, C, D. There is only one min term of this function. There is only one min term of this function. Very simple. Your wish, you can write, not a problem. Yes. Sai Kumar, please wait. I'm talking about the K-map questions, sir. Wherever you have doubts. Moving to 9th question. Read the question. For the K-map shown in the given, the minimum Boolean function is. The minimum Boolean function is. 9th question. It is given like this. K-map is given. Here it is X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, and this is given. Most of you might have done very simple. Right up. Let me write options also. Option A is X bar, Y bar plus Z bar plus YZ. Option B, X Z bar plus Z plus ZY bar. Option C, XY plus Z plus Y bar Z. Option D, X bar Z bar plus YZ. What is there in this? Very simple, right? Grouping. This one plus this one and also this one. Then what we are getting here? X bar. Correct. Next, what is this one? Y plus what is it here? Z bar. But option is not there. Am I right? In the options, it is not there. In the options, it is not there. Then what should I do? Right? We should go with the verification. Remember this, sir. When it is given minimal only, we should go with this. Remember these conditions, what I have been mentioning now, because these are important, which are leading to wrong perceptions about a question. Generally, we think that options may be wrong. Options may be wrong. That's what you may be thinking. That's what you may be thinking, right? Options may be wrong. Now, listen to me carefully. When it is given minimized expression, minimum expression, functionally equal, equivalent to, these words are very dangerous in a K-map or minimization. Remember words correctly. minimum expression, minimized expression equal to, in these cases, it may not be minimal. Minimized, minimum, functionally equal, these are not minimal. These may not be minimal. Sometimes it may be, but every time it may not be minimal. Then what is it here we need to check? It is minimized to some extent. There may be possibility for further minimization. There may be possibility for further minimization. Then simple thing is verifying with the functionality. Verifying with the functionality. Check it correctly. Verifying with functionality. Then how can I do that? Again using writing K-map for option A, option B, option C, option D. Simply writing K-map. It is very easy to verify. Once again, what is it here? When in the question represented by, function represented by, function equal to minimized expression, minimum expression, other than minimal. When these are given, there will be confusion because they may not be giving minimal expression. They might have minimized to some extent. There may be possibility for further minimization. So how they are minimized, we don't know. Instead of doing that, we can go with the verifications. Whichever the expression is functionally equal to this given K-map, that is the correct answer. Once again, try to understand this correctly. Function represented by, function equal to minimum expression, minimized expression. These are dangerous words with respect to K-map or Boolean expression. Are very dangerous because you are getting answer. It is not there in the option. Then immediately what we get here, opinion? Options may be wrong. No. Then what should I do? So you need to write K-map easily or quickly. If I write K-map for option A, K-map for option A, let us see what can be there. If I write K-map for option A, when it is not given minimal expression, there can be minimized expression. So it is minimized to some extent, not fully. X, Y, Z. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. X bar, Y bar. That means X equal to 0, Y equals to 0. These are min terms. First term. Anyone has any doubt? First term is what? X bar, Y bar. X equal to 0, Y equal to 0. I am writing K-map. Some of you are requesting for that also. How to write K-map when expression is given? Yes, this is X bar, Y bar. Next, what is that here? Z bar. That means wherever Z is 0, there it must be min term. So Z bar means Z equal to 0 region is this one. Am I right? This is Z region. This is Z region. Z equal to 0 region is what? This one. Any doubt in that? Z equal to 0. X is changing and Y is changing. That means these two min terms. What about third term? YZ. That means Y equals 1, Z equals to 1. Y equals to 1. Is it functionally equal? So it is not grouped prime implicants. It is not given minimal expression. Because it is mentioned minimum expression, minimized expression, functionally equal, represented by. These are very dangerous. Check it correct. If you are writing K-map for option A, then it is equal. Right? Even though we are learning all the concepts correctly, then, right? Yes, correct. We are going with the options. Yes. Yes, that is correct, Pranit. A schedule, if you want to know, right? The different branches have different schedules. because some people are worrying about schedule. Let me give that schedule also, right? Yeah, for all, 7 a.m. to 10 a.m. digital for all. 7 a.m. to 10 a.m. digital, and 2 p.m. to 4:45 p.m. numerical ability. 2 p.m. to 4:45 p.m. numerical ability for all, and 5 p.m. to 8:30 p.m. EMTL for EC, protection for EE electrical, transducers for iron instrumentation. Once again, schedule for all: 7 a.m. to 10 a.m. digital, 2 p.m. to 4:45 p.m. numerical ability, 5 p.m. to 8:30 p.m. different subjects for different branches. For EC, EMTL, for EE protection, for iron instrumentation, it is a transducers. Okay. So our digital subject schedule is 7 a.m. to 10 a.m. Yeah, it is lengthy only because if we don't have digital, there would be easy, right? Comfortable. Yes, we have to check. Anand, yes. Yes. They do, Pranita. I already informed your request, right? For EE, you have protection from 5 p.m. to 8:30 p.m. Revant Kumar. क्या हुआ साहिल सिंह अब मजा आएगा wait almost a day you will come to know Ankur. Yeah, it will not be there, but yeah, Neha, please, I will discuss all those questions, but I'm giving time to complete yourself. I will answer all those questions until our digital is completed, Annapurni. Our digital is completed, then only afternoon schedule will be there for you. Right? Until digital will be completed, after that only afternoon schedule for you. Is it fine? So, your wish. You want me to take more hours a day or more days, less number of hours per day? That's up to you. Yeah, Pratyusha, wait. The problem here is if I start at 10 a.m., for example, 10 a.m. to 1 p.m. I have to take. Pratyusha, please understand the situation. If I take 10 a.m., around 10 a.m., morning you may be getting up later, right? And from 10 a.m., 8:30 p.m. continuously class will be there. If I wind up by 10 a.m., from 10 to 2, you may be taking a rest or you may be going through any of the subject. It is possible until digital is completed. Afterwards, there won't be any such full schedules. Please understand the situation. Why I have chosen 7 a.m. to 10 a.m. Reason is if I start at 10 a.m. to 1 p.m., for example, every day 10 a.m. to 1 p.m., then from 10 to 8:30 p.m. continuously feeding is very difficult. 7 a.m. to 10 a.m. completed. Then you are getting 4 hours gap. In that you may be going through my subject or you may be going through any of the subject or you may be taking a rest also. How many days that we decide until we complete digital certificates? That is the reason I have chosen 7 a.m. to 10 a.m. Is that fine or shall I take 10 to 1? Yes, Manisha. Right? Yes, we do our best. 8 to 11. I will check it. I will check it. Yeah, it's my suggestion only 7 to 10. It's my interest only to take 7 to 10 for digital, because after 10, yeah, there is a reason I have chosen 7 to 10. I think it is best time for everyone, because the 4 hours you may be taking rest, or you may be taking preparation, or your wish, whatever it be. Otherwise, if I start at 10 a.m., you may be getting up at 8 or 8:30. Then what happens? Full day classes after getting up. So that is not the good thing. That is the reason I have chosen this 7 a.m. to 10 a.m. So we'll see how it will be for you and for me also. Yeah. Thank you everyone for your cooperation. Not every day. For your information, some of you are worrying about this many. No. Actually, it is for few days only until we complete digital circuits. Because of new batch, the schedules have been getting disturbed. Otherwise, only digital would have been there. Because of new batches are getting started, the schedules are disturbed. Otherwise, it would be very much fine with only digital. Yes, Teja. But what can we do? Bear with me for a few days, right? Neeli Teja. Yes, sir. For a few days only. Yeah, they do all these things, Pranita. Depending on other batches also, they have to take the decisions, sir. Arun Revanta, still you are in PG? Yes, Manisha, I'm there to help you always, sir. I'm there to frame new questions also for you. That depends. Tanganateshwaran. I'm sorry if I'm pronouncing wrongly. So I don't know. Yeah, yes, Bhavani, it is there. Yes, that's what I'm planning to actually do. Most awaiting topic for me. Ramya, please uh, do some arrangements, because right, even if I start at 8, you'll be having a problem, Ramya. Yeah, wait, Anjanelu. Yeah, they are planning about materials, Shubham. Please wait. Yeah, that's what I'm planning. Most of you are accepting for 7 o'clock schedule only. Pawan Kumar, you are giving me a discount, 30 minutes. Right, I'll try to wind up early by starting early. That I'll change. We're having some problems like 6 to 9 or 6:30 to 9:30. Somehow I will manage. If not 7, right? Yes. Yes, sir. Surya Teja, I'll give you. Mr. Solving, I'll give you some more questions on that. I will give you. Okay. Anyway, I would like to start tomorrow sequential circuits, sir. Tomorrow sequential circuits, sir. So be ready and have some energy, right? If possible, right? Have a good coffee in the morning and having some dry fruits or fruits. You come with energy in the morning because sequential is interesting and more scoring. I think no one is having any doubt with respect to schedules. Few days, Bhavani, why are you worrying about that? Few days only. Afterwards, only half day. Because of new batch schedule has been changed, our digital has been shifted. Otherwise, if I would have speeded up for information, if I would have planned by today or tomorrow, if it is required to be completed, then I would have done with more speed with less examples. Bhavani, you need to understand a situation. If I would have run with high speed and less examples, by tomorrow I would have completed digital circuits. If you are expecting that, this problem would have not there. But I wanted to give my best with moderate speed and good examples I wanted to cover. That is the reason it is taken more days. That is the reason it happened. Otherwise, it would have been completed by tomorrow. Then there will be only off-day sessions. People have been worrying about schedules. Ujjwal, already mentioned 7 a.m. to 10 a.m. our digital circuits. Bhavani, please understand. Don't worry about the 3 subjects and so and so. Few days only. The reason is already I mentioned. It is planned to complete by tomorrow. But I don't want to rush to complete the syllabus because it is having good weightage. It is having a logical analysis. If I speed up, people will not understand a single word also. If I don't cover with these examples which I have covered, then students will not be understanding the concept. That is the reason it happened. Please understand all these things. Anand, why you are saying that? I didn't understand. What is that? My intention is everyone should get benefits of this coaching. Yes, that's what I've been trying. Yeah, please bear with me, at least for me, not for institute. I'm requesting from my side, bear for me because I want to give my best. Requesting you to accept my concept, right? Please, requesting you, not from institute side, from my side, I'm requesting you, bear with me few more days. After that, you will be having only half day sessions, right? Is that fine now? Will there be any problems, sir? So please manage your things, sir. Right? Please manage your things, sir, accordingly. I will discuss all the questions, Arunachalam. Give me some time. Let them try, everyone. I will solve, especially question number 2. People might be worrying about that. Not only that, we have one more question similar to that 2017 GATE EC. So in understanding question number 2, people may be struggling. I will give you, right, another question which was given in gate EC. And please bear me instead of institute, bear me, right? Please, if you have any doubts, you can raise the hands for today's discussion. Bharat.
Sir.
Yes, Bharat.
Sir, slide number 11, 12, 13, sir.
Okay, I'm going to that. 11.
Yes, sir. దీని తర్వాత వచ్చే ఎగ్జాంపుల్ అర్థం కాలేదు సార్.
ఇది రాలేదా?
అవును సార్.
ఇప్పుడు ఏం చేస్తాము? ఈ కరెక్ట్ మొత్తం సర్క్యూట్ రాయడం అంటే కష్టము, నేను చెప్తాను. ఒక 3 to 8 ఉంది.
ఓకే.
ఇక్కడ ఎన్ని 3 to 8 కావాలి? మళ్ళీ ఎండ్ స్టేజ్ లో 8 కావాలి కదా?
అవును సార్.
ఈ 8 దేంతో ఎనేబుల్ చేస్తాము? ఈ 8 అవుట్పుట్స్ చేస్తాం.
అవును సార్.
ఇంకే డౌట్ ఏంటి చెప్పు? ఇక్కడేమో ఏబిసి ఇస్తాము, ఇక్కడ అన్నిటిలోనేమో
ఏబిసి 1 డిఎఫ్ 8 ఎట్లా ఇస్తున్నారని అర్థం కాలేదు.
ఇప్పుడు ఇక్కడ అన్నిటికీ డిఎఫ్ ఇస్తాను.
అవును సార్.
ఎనేబులింగ్ ఏం చేస్తాను? ఈ 3 to 8 కూడా అవుట్పుట్స్ ఉన్నాయి కదా, అవి ఎనేబుల్ కింద యూజ్ చేస్తాను.
అవును సార్.
ప్రాబ్లమా? ఇక్కడ ఏంటి 2 యూజ్ చేసి మళ్ళీ 2 ఇక్కడ పెట్టాము.
అవును సార్.
ఇక్కడ ఏంటి 3 ఒక స్టేజ్ లో ఇచ్చేసి మిగతా 3 అన్నిటికీ ఇస్తాం. ఎలా చేసాము? ఇక్కడ సిడి అన్నిటికి ఇచ్చాము, అలాగే డిఎఫ్ అన్ని 3 to 8 కార్డ్స్ ఇస్తాం.
ఓకే ఓకే
భరత్.
సార్ ఓకే సార్.
ఇంకా అంతేనా?
అంతే సార్.
ఓకే, థాంక్యూ.
సార్ షెడ్యూల్ ప్రకారం సార్ యాక్చువల్ గా మనకు పర్ డే వచ్చేసి 6 hours నుంచి 7 hours తీసుకోవాలి కదా సార్?
తీసుకోవాలి నాన్న, మళ్ళీ మళ్ళీ అదే చెప్తున్నావు. నా వల్ల అవుతుంది, ఈ ప్రాబ్లం అంతా నా వల్ల అవుతుంది. ఏం చేయమంటావు చెప్పు?
అట్లని కాదు సార్, అంటే ఫుల్ డే క్లాసెస్ ఉంటే మాకు
నేను స్పీడప్
సిలబస్ కంప్లీట్ చేయడం కాదు కదా సార్. సిలబస్ ఇప్పుడు 1 day లో కూడా కంప్లీట్ చేయొచ్చు మీరు తలుచుకుంటే. అది మెయిన్ కాదు కదా, మేము కూడా నేర్చుకోవాలి కదా సార్.
అందుకే కదా నాన్న నేర్చుకోవాలని ఇంత తపన పడి నేను చెప్తున్నది. ఇప్పుడు నేను ఆపేయమంటావా? తర్వాత ఎప్పుడు చెప్పుకుందామా? అది కష్టం కదా.
అవును సార్.
కదా, మళ్ళీ గ్యాప్ వచ్చింది అనుకో, మళ్ళీ రివైజ్ చేసుకొని చాలా టైం పడుతుంది.
అవునవును.
అలాగని ఆఫ్టర్నూన్ క్లాసులు కంటిన్యూ చేయాల్సి వస్తుంది, ఎందుకంటే కొత్త స్టూడెంట్స్ యాడ్ అవుతున్నారు కదా, వాళ్ళకి కూడా మళ్ళీ 6 hours ఇవ్వకపోతే బాగోదు కదా.
ఓకే సార్.
వాళ్ళకి 6 hours ఇవ్వాలి, కానీ నా సబ్జెక్ట్ మిగిలి ఉండడం వల్ల ఈ ప్రాబ్లం. అర్థమైందా? రకంగా చెప్పాలంటే ఇది నా ఫాల్ట్ అనుకో. నేను ఉన్న టైంలో కంప్లీట్ చేయలేకపోయా. ఎందుకు చేయలేకపోయా? కాన్సెప్ట్స్ కవర్ చేయాలని ఇంటెన్షన్ తో.
అవును సార్.
ఇంత నిదానం చెప్తేనే కొంతమందికి అర్థం కావట్లేదు కదా. ఇంకా నేను స్పీడప్ అయ్యాను అనుకో, ఏం చేయాలి? కొంచెం స్పీడప్ అవ్వాలి, ఎగ్జాంపుల్స్ కట్ చేయాలి. చేస్తే ఏమవుతుంది? కాన్సెప్ట్ కవర్ అవ్వదు. అవ్వకపోతే ఏమవుతుంది? ఎగ్జామ్ తర్వాత తిట్టుకుంటావు, అంతేగా. అది నా ఇంటెన్షన్ ఎప్పుడు కూడా అది కాదు. నేను తీసుకున్నానా ఫుల్ కవర్ చేస్తాను. అందుకని ఐఎమ్ రిక్వెస్టింగ్ యూ.
మీ టైమింగ్స్ ఓకే సార్, కాకపోతే తర్వాత వచ్చే టైమింగ్స్
అన్ని చెప్పా కదా. ఇంకో బ్యాచ్ స్టార్ట్ అవడం వల్ల వాళ్ళకి కూడా ఒక 6 hours ఇవ్వాలి కాబట్టి, 5-6 hours కనీసం ఇవ్వాలి కాబట్టి రోజు వాళ్ళతో కలిపి మీకు ఆ సబ్జెక్ట్ ఉంటుంది. రైట్, కొద్దిగా బేర్ చేయండి, నా సబ్జెక్ట్ అయిపోయే వరకు బేర్ చేయండి. రైట్, తర్వాత మళ్ళీ మీకు హాఫ్ డే మాత్రమే ఉంటుంది.
థ్యాంక్ యూ సార్.
ఓకే,
రైట్.
యుగశ్రీ.
Sir.
Madam, tell me.
Yes, sir. Sir, am I audible?
Yeah, tell me.
Sir, దీని తర్వాతకి వచ్చిన ప్రాబ్లం చూపారు సార్.
ఒక్క నిమిషం.
పేజ్ నెంబర్ 14F.
14F. Okay. What up?
సార్ ఇది ఎస్ఓపి పిఓఎస్ ఉంది కదా సార్.
ఇది ఎస్ఓపి, ఇది కూడా ఎస్ఓపి.
ఎస్ఓపి పిఓఎస్ కదా
ఇది
సార్.
రెండు POS.
అయితే మీరు ద నెక్స్ట్ పేజ్ లో ద నెక్స్ట్
వన్ ఎస్ఓపి,
సార్
Two
2
SOP.
కి 4 కి గేట్ ఇచ్చారు కదా సార్. ఇక్కడ Y0 Y1 దానికి ముందే నాట్ ఎందుకు ఇస్తున్నారు సార్?
ఇక్కడ బబుల్ పెట్టడం వల్ల ఏంటంటే ఇక్కడ వచ్చే ఎక్స్ప్రెషన్ రిప్రజెంట్ చేస్తున్నాను. ఈ బబుల్ పెట్టడం వల్ల అంటే లాజిక్ 0 అవుట్పుట్స్ అవుతున్నాయి కాబట్టి ఇక్కడ వచ్చే ఎక్స్ప్రెషన్ ప్రొడక్ట్ టర్మ్ కాదు సమ్ టర్మ్ అని ఇండికేషన్ అన్నమాట.
ఓకే, హోల్ బార్ ఉన్నందుకు పెట్టుకున్నాము.
ఏ బార్ బి బార్ సి బార్. ఇప్పుడు వితౌట్ బబుల్ ఏమొస్తుంది? ఏ బార్ బి బార్ సి బార్ వస్తుంది. ఈ బబుల్ ఉండడం వల్ల ఏమొచ్చింది? ఏ ప్లస్ బి ప్లస్ సి వచ్చింది. ఈ బబుల్ లేకుండా ఉంటే ఏమొచ్చింది? ఇక్కడ ఏ బార్ బి బార్ సి బార్ వచ్చింది. బబుల్ పెట్టడం వల్ల ఏమొచ్చింది? కాంప్లిమెంట్ ఆఫ్ దిస్ వచ్చింది. అదేనా? అంతే కదా.
సార్ డికోడర్స్ అవన్నీ ఎక్కడ అప్లికబుల్ అవుతాయి సార్?
ఏమా ఏవి?
డికోడర్స్ అవన్నీ ఎక్కడ అప్లికబుల్ అవుతాయి?
స్విచ్చింగ్ నెట్వర్క్ లో అవుతుంది, ఎన్కోడింగ్ ప్రాసెస్ లో అవుతుంది,
సార్ సార్